Okay. Hello, everybody, and welcome to your third week of Online World. It's April 6th, 2020, and we are going to talk today about extinction. Very exciting topic. So this week, we're going to work on extinction and its prevention, right, for the whole week. So just a couple announcements before we get started. First of all, congrats to everybody for taking your exam successfully online on Friday. I had all but a few students make it into the exam or arrange another setup with me. So thank you for that. I will not be able to grade those until this coming weekend. Just don't have the time. But I will do that this weekend, and I'll get the grades posted up on Moodle for you so you can check them. Okay, so the one other announcement that I have is that this Wednesday, I'm going to start with the new format of the class. So it's not a big change, but I had asked you guys to give feedback last week on how you felt about the Wednesday workshops, if you'd prefer to have like the first 20 minutes of class be live so that we could meet face to face and talk, and I could introduce the workshop to you and you could ask questions. And you responded on the forum. Thank you for that. A few people said that would cut into their time to work on the workshop, but most people said they did want that. So I am going to do that on Wednesdays. It is optional. You can always watch the video later if you prefer. But I hope many of you will join me on Wednesday at 1 o'clock. I'll send you a Zoom link that you can click on, and I hope to talk to you then because I miss seeing you. Okay, so let's talk about extinction. Cheery topic. Okay, so today, we're going to do this first video. This is me giving you the lecture piece about extinction. Then the second video is up there, and it's two college students doing their own really cool, informative video about extinction. And then I got a kitten for my kids to play with during this, and he's very needy. So he's going to have to hang out here with us. So then I put up 2 optional videos as well for you to watch, and those are videos like what extent will people go to stop extinction, and they're pretty interesting videos. So if you have the time, check out those videos, which are just for fun, and then do mini assessment 1. Okay, so extinction. The cat finds it as upsetting as we all do. There's some great extinction art out there. This is just one example. He's gonna have to go. Sorry about that. So extinction is not only caused by massive asteroids that hit the Earth and wipe out the dinosaurs, although that type of extinction has inspired a lot of cool art. Let's look at what else extinction is. Okay, so let's actually start way back and talk about who was Mary Anning. We were in class, I'd see if anyone knew, but I bet nobody does, because she's a fairly obscure figure. But she is the reason that we accept extinction as a process. She was actually lived a long time ago. She was born in 1799, and she was a British fossil collector, dealer, and paleontologist. This was very uncommon for women back then, right? But she managed to make a name for herself in this field. So she discovered an ichthyosaur skeleton on some land near her family's house when she was just 12 years old, and she sketched it. And before this, people had basically believed that extinction couldn't happen because that would be blasphemy, because if the Christian God created the earth in 7 days, then why would he have created anything that wouldn't last forever? He wouldn't have. So therefore, there can't be any organisms that go extinct because that's not God's will. This was the belief in Western Christian civilization. When Mary Anning started discovering these species like ichthyosaurs, that idea changed, because essentially people thought, how could this be? This doesn't exist anywhere on Earth. There's no other explanation for this than that it must have existed once and now no longer does. So people started to accept that extinction was a real process. Here's some other crazy things that she discovered. Dinosaur fans will know what those are. I don't remember. Oh, that's the ichthyosaur, sorry. So that's the ichthyosaur skeleton up there, and people just kind of, it looks like a platypus combined with a fish, right? That there couldn't possibly be anything like this alive on Earth now. No one had ever seen it. Extinction must be real. Okay, so what are some vocab terms we need to know for extinction? Well, extinct, hopefully everyone knows what that means. It means gone forever. There's extirpated, that's a little more complicated, and there's extant. So take a minute and think to yourself, do you have any idea what these other two mean? This is what they mean. So extirpated means they're gone from a certain area, but not from Earth. So like wolves have been extirpated from the Adirondacks. We still have wolves on Earth, but we killed them all out in the Adirondacks. Extant, that's species that are still here. So any species that's still around is an extant species. There is one other level, and it's called the living dead. They're not zombies. They're species that have extant individuals, but there's not enough for them to breed and survive and recover the population. So maybe there's just like one male left, or there's just 2 or 3 females, but they're too old to reproduce. Any of these situations essentially mean that we still have the species, but they're functionally extinct. And that's really sad to watch, right? And it is the case for some of these species here at the bottom, the white rhino, a tarsier, a little tiny primate found in Madagascar, and the Chinese freshwater dolphin. So those species are already gone, really, but we can still see the few individuals that are left. Okay, so I kind of already talked about this, but essentially people didn't accept Mary Anning's, or before Mary Anning, people didn't accept the concept of extinction. It had been proposed, but for religious reasons, people didn't believe it. But thanks to Mary Anning, we began to move towards this understanding that species do go extinct. Okay, but what causes extinction? How does it happen? Well, extinction essentially happens when, one, a species is no longer well adapted enough to its environment to be able to stay healthy, grow to adulthood, and reproduce successfully, and it can't evolve quickly enough to adapt. So there's a little tree of life you can see down there. You can see that many, many branches on the tree of life haven't made it to the end of the tree of life, which is today, right? The edge of that tree is today, the species alive now. Those branches went extinct because they weren't adapted to their environment. Maybe their environment changed, so they couldn't make more individuals, and they didn't have the ability, they didn't have maybe the genetic variation in their population to allow them to evolve quickly enough to adapt. So, is this always humans' fault? Of course not. Extinctions we tend to associate now with people, but extinctions have always been happening. Like it says here, more than 99% of species that have ever lived are now extinct through mostly natural processes until humans arrived. We estimate, although this is a very rough estimate, that there's about 5 billion species that have ever lived on Earth. It's a crazy number. And as you guys, of course, remember, there's 8 million estimated to be here now. Okay, so what causes extinction? Well, there's 2 kinds of extinction. This is an important thing to learn from today. There's background extinction, which is the normal or average rate of extinction. Then there's mass extinction, which is the statistically significant increase of extinction beyond background rate. What causes background extinction? Just normal extinction. Your everyday blinking out of a species on Earth. Well, one thing that causes it is predation. So it says their organisms must be suited to their abiotic and biotic environment. So if all of a sudden in your environment, for example, this clam here, this is an Inoceramid clam. This clam lived in an environment where it was predated on by an unknown predator, but it made these marks in its shell where that arrow is pointing. You can see that dent. And the Inoceramid clam was doing really well for millions of years, but then as you can see in this graph, what those blue lines show is the percent of Inoceramid clams showing evidence of a predator attack. You can see that the oldest clams showed no evidence, so life was good. But as time went on, a new predator arrived on the scene and started eating them. And then over over much more time, the percent of clams showing predator attack was close to 40%. So this species actually went extinct shortly after that. So they could not adapt to this new predator on the scene, right? They're too slow to adapt, so they went extinct. Competition can also cause this. So we've talked a little bit about competition before, but basically it's like if a new species, we talked about this with invasive species, right? So if an invasive species comes to a new area and the native species can't compete, then the native species will go extinct. So this has also happened throughout evolutionary time. So if you look at this graph, on the bottom, it's showing millions of years, and on the side, it's showing basically like how much of this particular taxa of plants is found in the fossil record. So, okay, so what we're seeing here is, for example, a wildly successful species group of plants is angiosperms at the very bottom, the flowering plants. So if you look at from like about halfway through that time, like 213 million years ago, you can see that there's a lot of these other things, cycads, ginkgoales, chitonales, benetitionales, not sure how to pronounce that one. But the important point to see is that when angiosperms take off around 150 million years ago and start increasing, many of those groups go down to almost zero. In some cases zero, in some cases they persist, of course, like the ferns, but at much lower numbers. So this is a case of competition. Angiosperms are so good at being plants that flowering gives them such an advantage through sexual reproduction that they have beaten out a lot of the other plant taxa. Okay, oops, I'm covering something up here. So what's another reason that causes background extinction? Disease, right? So if you haven't seen the sad sight down here on the right, this is actually boreal toads killed by chytrid fungus in the Rocky Mountains. So this chytrid fungus is killing a lot of amphibians worldwide, and this is causing extinction of some amphibian species. Now, in this case, it was introduced by humans. Fishermen or people using the water recreationally carry these spores on their boots from one place to another. And so they've gotten in, they're originally from Africa, this fungus, but it's gotten into waterways worldwide. So why aren't species driven extinct by diseases that aren't introduced by humans? What do you think? I hope you got the right answer there. But the answer is because essentially, if they evolved with a disease, they'd already have resistance to it. We see this right now with coronavirus, right? When you get the common cold, the vast majority of people aren't going to die from that because we've evolved with the cold and we have resistance to it. This coronavirus, COVID-19, is a novel virus. So it's having a high mortality rate because we haven't evolved with it, right? So when you evolve with a disease, you build up mortality immunity, because only the individuals that have immunity survive. A dark thing to think about in this time, right? Okay, so what causes background extinction? A lot of times it's not just one thing. It's not just predation, just competition, or just disease. It's a combination of factors that are just kind of like too much for the species to bear. So I'm going to tell you about a case of this called the Channel Island case. So if you can't feel bad about this adorable little fox going extinct, then I don't know what's wrong with you. So this little fox here, they're the Channel Island foxes, and they're kit foxes. They're tiny. I should have put in a picture with people, but they're about this big. So they're adorable little foxes, following the trend of many island species, which is to be smaller than the mainland version of that species. The Channel Islands, if you've ever been there, are off the coast of Los Angeles in California. You can see them there in green. And these islands are a national park. They're really special. They have a lot of unique biodiversity. So what happened or is happening now to the Channel Island foxes? They're on the verge of extinction, but it's because of a combination of things. So if you look at this graphic on the right, basically back in the day, pirates, supposedly pirates, but lots of people who sailed on ships would leave pigs on islands that they passed so that the next time they passed there, they would have a good food source to hunt. So they're like seeding the world with bacon. This had a lot of terrible unintended effects because feral pigs are really generalist predators. So the pigs that were released there actually don't eat the foxes directly, but they attracted a new predator to the area, which is golden eagles. Golden eagles didn't used to come out to the islands, but then they started coming out to the islands because of all the delicious piggies. But then they started preying on the foxes as well. And the foxes predate skunks. They eat skunks. So they were previously keeping the skunks in check, but then the skunks population started to increase dramatically, and skunks will kill and eat baby foxes. So now the kits, they're called. So now the foxes are facing this double whammy of predation that they've never experienced before. And this is driving them to the point of extinction. Now, I'm telling you this as an example of background extinction, but this combination of competition and predation really wouldn't have happened if humans hadn't brought pigs to the island, right? So human-caused extinction is hard to think of as background extinction. It's actually easier to think of as a mass extinction. So what the heck is a mass extinction? Well, we already defined it, right, as when the extinction rate is statistically significantly different than the normal background rate. Excuse me. So here's a graph of this. On the bottom, it shows millions of years. On the side, it shows extinction rate. And those peaks are mass extinctions. You can see they really stand out. And I want you to notice something else about them. If we were in class, I'd just ask you this. Who can look at the width of those extinction peaks? That shows how long they took to happen. Did they take 20 years? 200 years? 500,000 years? Millions of years? They took millions of years, right? Millions of years. Keep that in mind. Okay, here's the gratuitous meteorite picture. There's several of them in this presentation. So what caused those 5 mass extinctions before now? Only one was caused by an asteroid, as far as we know. There was the Ordovician 500 million years ago. 50% of animal species went extinct. In the Devonian, 345 million years ago, 30% of animal families. But the real daddy of them all was the Permian extinction 250 million years ago. And more than 90% of all species on Earth went extinct. It's just fascinating to think about that. We almost lost life on Earth, right, during that time. And then we had a smaller extinction event in the Triassic, and then we had the famous one in the Cretaceous 65 million years ago. The most recent one, when the asteroid ended the dinosaurs. So, okay, there's that awesome gratuitous asteroid pic down there. Well, that's not a picture, right? It's art. And these other ones are art as well. Paintings, right? But we think that we don't know for sure what caused all the extinction events, but it always looks like there's something in the fossil record or in the geological record that indicates that during that time or just prior to that time, there were either volcanic eruptions, asteroids in the Cretaceous, or global climate change and massive changes in ocean chemistry. So if those last two things sound kind of familiar from the workshop last week, then you're thinking along the right track, right? We are currently experiencing global climate change and changes in ocean chemistry, right? So it's a little scary to think that the situation we're creating now with climate change is similar to situations that have caused mass extinction events in the past. And that brings me to the 6th extinction, right? The 6th mass extinction. There's this famous book published about 10 years ago that won the Pulitzer Prize called The 6th Extinction by Elizabeth Kolbert. And this is a great book, definitely worth checking out. It's a really interesting read, but essentially what she's talking about and presenting a ton of evidence about is that current extinction rates are not at the rate of background extinction. They're on a par with past mass extinction rates. But unlike unlike past mass extinction events, they're not happening over millions of years or thousands of years. They're happening past 200 years, right? Just since the Industrial Revolution. So we've had extinctions in the past. We've had mass extinctions and come back from them. But we've never had extinctions happening quite this quickly. So I'm gonna have to move here because I have to plug in my computer. Okay. Here we go. So we talked about this one here in class already, right? The prehistoric overkill hypothesis. Now, the prehistoric overkill hypothesis, just to refresh your memories, essentially refers to the fact that, like you can see in this graph in green, every time that Homo sapiens entered a continent, the megafauna population went way, way down shortly after. With the exception of Africa, because, I hope you guys remember why, because as we talked about, megafauna evolved with humans in Africa because humans evolved in Africa. So just like diseases that we evolve with, humans that evolve with people, animals are used to them. They're adapted to that predator, which is not the case in the other places. So you might say this is our MO, driving species extinct. Let's hope not. Back then we didn't have awareness of what we were really doing, right? But now we do. So now we have a responsibility to change. So I've showed you this graph in the past as well. So we know all these things that are causing, we've already covered in class many different issues that are threatening biodiversity. But here's a graphic just showing in the distant past for marine species and mammals, taxa that we have good fossils for, right? The extinction rate was down here in the distant past over long periods of time. Right here, it's up to 1,000 times higher than the fossil record, because this here is a logarithmic scale, right? It goes by orders of magnitude. Over here, the future modeled rate is going to be even higher than the current rate. And, okay. Well, let me go through this and then I want to talk about something here. Where can I go? Here. Okay, so why can't species just evolve to keep up with global changes? We know that species have a great capacity to evolve and that evolution is always happening. But the thing is, like the theme of this whole lecture is that the current changes are too fast. The reason why 90% of species went extinct in the Permian extinction is because as the record shows, it happened relatively quickly in evolutionary time. It happened over only a couple million years. So essentially that was too fast for species to adapt. And now it's happening over just hundreds of years or thousands if you want to go all the way back to the prehistoric overkill hypothesis. So conditions on Earth are changing too fast. There's no way evolution can happen that fast, especially not for larger organisms who reproduce slowly. So what species will survive all this rapid change? This should look kind of familiar to you. It should look kind of like the ones that are going to survive overexploitation. So I'm covering this over here. If you don't know what that is, it's a European starling. It's an invasive species in the United States. But the ones that will survive are large populations that have a large geographic range. So they exist in so many places that if something bad happens in one place, they'll still have other populations in another place. Interconnected populations, so they have high genetic diversity. That helps with adaptation. Fast generation time, so like you trap mice one year, the remaining ones have babies and there's just as many the next year. Many offspring, habitat generalists. Boy, you kick a raccoon out of one part of the woods or your yard, it'll just show up in another part, right? He's a generalist. And of course, species that are not delicious. So species that people don't hunt to extinction for eating. So that includes some cool species, right? Starlings are beautiful. Rats are pretty cool and very intelligent. Coyotes are awesome. But we're going to lose so many other species if we don't do something about it. we can't have, our ecosystems will be vastly simplified. And as you already learned in other parts of class, simpler, less biodiverse ecosystems are more fragile. So I put this in because it's a bonsai tree. Those are miniature trees that people in, I'm not sure exactly where this originated, I think Japan. But the idea is to cut the tree so much when it's young that it only grows very tiny and produces a beautiful tiny miniature tree. But we don't want a miniature tree of life, right? We don't want a little bonsai tree of life with just us, rats, cockroaches, starlings, and coyotes. We want all the other biodiversity that's on Earth because, as we learned in our ecosystem services section, we need that biodiversity. So it's not just a moral obligation to protect these species, we need them. We're not gonna live happily in this bonsai tree. Okay, so that's all for this lecture for today. For Wednesday, I just want to remind you again that the first 20 minutes from 1 to 1:20 will be live on Zoom, so I can explain the workshop and answer any questions. I will put a Zoom link on Moodle, and I'll record the video. In case you can't make it, you can watch that anytime. So please go ahead and watch the one required video for today, and then you can do the mini assessment. And I will see you all on Wednesday. You can stop watching this, I just can't turn it off.